Okay, friends, next topic, Perkin reaction. It is one of the important reaction of aldehydes. Let's see what is Perkin reaction. It is condensation of an aromatic aldehyde with aliphatic acid anhydride containing at least 2 alpha hydrogen atoms in presence of sodium or potassium salt of corresponding acid to form alpha beta unsaturated acid. Now let's understand this reaction with an example. First, benzaldehyde. It is reacted with acetic anhydride in presence of sodium acetate. Now that gives cinnamic acid with acetic acid. Okay. Second example, again benzaldehyde is reacted with acid anhydride in presence of sodium acetate. That gives alpha methyl cinnamic acid with propionic acid. Okay. Now, since a weak base is used in this reaction as a reagent, high temperature is required during Perkin reaction. Okay. The catalyst which we are using in this can be replaced by other bases such as sodium carbonate or pyridine or trimethylamine, etc. Okay. Now let's understand the mechanism of this reaction. Perkin reaction takes place between aldehyde and acid anhydride. Okay. Now in this case, the salt which we are using, it acts as a catalyst. Okay. How it takes place? How the reaction takes place? The reaction sequence will be described in 4 steps. In first step, this acid salt which we are using as a catalyst, it dissociates to give an anion. Okay. Now this anion, it reacts with your anhydride molecule. Okay. And abstracts one proton from one of the R group. In this case, we are using acetic anhydride, so it will abstract one proton from one of the 2 methyl groups to give acid anhydride anion in second step. Okay. And there is formation of acetic acid. So this second step is important. Okay. That is abstraction of proton from acid anhydride. Now in the third step, this acid anhydride anion reacts with aldehyde and there is fusion. These 2 molecules, they condense with each other. Okay. By abstracting one proton from the solvent, this proton is absorbed from second step, that is acetic acid, which it donates one proton to give us this complex, this acid complex. Okay. In the next step, this intermediate complex, it loses a water molecule to give unsaturated compound, and on hydrolysis, okay, here it is losing water molecule. In the next step, there is addition of water molecule. This addition of water molecule will take place across the anhydride part. Okay. And this bond will break and you will get alpha beta unsaturated acid plus another acid. Okay. So CH3 C double bond O, it will accept a proton, and at this place there is attachment of hydroxyl group. So this is what is hydrolysis. Okay. Now Perkin reaction proceeds more easily when there is when aldehyde contains an electron withdrawing group such as nitro group. So we will take example of para-nitrobenzaldehyde. Para-nitrobenzaldehyde when reacts with acetic anhydride in presence of sodium acetate, the yield of the product is para-nitrocinnamic acid and the yield is 82%. Remember this. Okay. But similarly, when electron releasing group, electron donating group such as alkyl methyl, This orthomethyl benzaldehyde gives orthomethylcinamic acid. You can write down this reaction, but the yield is only 15%, whereas in case of para-nitrobenzaldehyde the yield is 82%. Nitro group is electron withdrawing group, methyl is electron releasing group, donating group. So withdrawing group will increase the yield, releasing group will reduce the yield. And one more thing, para-dimethylamino-benzaldehyde does not give Perkin reaction. That means it does not react with acid anhydride. Okay, now let's see the applications of Perkin reaction. Salicylaldehyde undergoes Perkin reaction to form trans-O-hydroxyl coumaric acid. This is salicylaldehyde reacts with acetic anhydride to give O-hydroxy coumaric acid. Okay, now it loses water molecule to give coumarine. Okay, second application, furfural. Furfural reacts with acetic anhydride in presence of sodium acetate to give furyl acrylic acid. Okay, you can write down the mechanism if you want. Okay, next, anhydrides can also undergo Perkin reaction in place of aldehydes. Example, in this case we are using phthalic anhydride reacts with acetic anhydride to give phthalate acetic acid. Okay, now the reaction condition in this case is 150 degrees Celsius up to, we have to heat this reaction to get the product. Okay, so this is, in short, there are a number of applications of this Perkin reaction, but to restrict our discussion, I have taken few examples, few important examples. If you want more examples, I will put them all on our WhatsApp group in the form of notes, or even you can follow various websites. You can Google it and find out the applications of Perkin reactions. Remember, this is one of the important reaction of aldehydes, so it's important. Okay, thank you. With this discussion, if you have any doubt, you can comment it or you can contact me on our WhatsApp number. Thank you. See you in the next video.